Good morning. Today we'll discuss about the second law of thermodynamics. The second law of thermodynamics mainly identifies the direction of a process. That is, heat can only spontaneously transfer from a hot object to the cold object and not vice versa. And it is used to determine the quality of energy. Example, a high temperature energy source has a higher quality since it is easier to extract energy from it. It is used to exclude the possibility of constructing 100% efficient heat engine and perpetual motion machines. This violates the Kevin Planck and Clausius statements of the second law, used to introduce concepts of reversible process and irreversibilities, determines the theoretical performance limits of engineering systems. Example, a Carnot engine is theoretically the most efficient heat energy engine. Its performance can be used as a standard for other practical engines. Examples, a process cannot happen unless it satisfies both the first and second laws of thermodynamics. The first law characterizes the balance of energy, which defines the quantity of energy. And the second law defines the direction which the process can take place and its quality. Define an example, a development or designing of a heat engine, a device that converts heat into work while operating in a cycle. So here the delta Q is equal to delta U. That is, the change in the energy and the work done is equal to the change in the internal energy. The thermal efficiency is defined as the ratio of the work done, the net work done to the internal energy or the heat. So the examples for this is a steam power plant is a good example of heat engine where the working fluid water undergoes a thermodynamic cycle. Here the net work is equal to work done is equal to work done to the outside energy, and the work done internally is equal to heat internal minus heat outside. That is, the heat transferred from higher energy reservoir and is generally referred to the QH. Heat out is the heat transfer to the lower temperature reservoir and is generally referred to as QL. The thermal efficiency can be calculated as equal to net work done by the QH. It is equal to QH minus QL, ratio of QH, that is 1 minus QL by QH. This is a typical efficiency of a large commercial power plant. Thermal reservoir, a hypothetical body which is a very large thermal capacity to or from which heat can be transferred without changing its temperature. Example, oceans, atmosphere, large lakes. Let's discuss about what is Kevin Planck statement. A Kevin Planck statement is another expression of the second law of thermodynamics. It states that it is impossible for every device that operates on a cycle to receive heat from a single reservoir and produce net work. This statement is without proof. However, it has not been violated yet. Consequently, it is impossible to build a heat engine that is 100%. A heat engine has to reject some energy into a lower temperature sink in order to complete the cycle. That is, total heat TH is greater than TL in order to operate the engine. Therefore, the higher the temperature, the higher the quality of the energy sources and work is produced. Heat pumps and refrigerator. A heat pump is defined as a device that transfers heat from a low temperature source to a high temperature one. Example, a heat pump is used to extract energy from the outside cold outdoor air into the warm indoors. A refrigerator performs the same function. The difference between the two is in the type of heat transfer that needs to be optimized. The efficiencies of heat pumps and refrigerators are denoted by coefficient of performance. Clausius statement. The Clausius statement is another expression of the second law of thermodynamics. It states that It is impossible to construct a device that operates in a cycle and produces no effect other than the transfer of heat from a lower temperature body to a higher temperature body. Similar to the KP statement, it is a negative statement and has no proof, but it is based on the experimental observations and has not yet been violated. Heat can be transferred from lower temperatures to higher temperatures unless external work is supplied. Therefore, it is impossible to build a heat pump or a refrigerator without external output. Equivalence of these two statements. It can be shown that the violation of one statement leads to the violation of the other statement, that is the equivalent. A 100% heat efficient heat engine violates KP statement because the heat transfer from lower body to the higher body without work is impossible. Perpetual motion machines. Imagine that if we can extract energy from unlimited low temperature energy sources such as the ocean or the atmosphere. So it is against the KP statement. It is impossible to build a 100% heat engine. So perpetual motion machines can be classified into two types. One is perpetual motion machine of first kind and the perpetual motion machine of second kind. The first kind violates the first law of thermodynamics, second kind violates the second law of thermodynamics. So these are some of the self-assessment questions on the second law of thermodynamics. Thank you.